Okay, we are given this question. The integral of e raised to the power 2x cos 7x dx. I'm going to solve this within 1 minute. I'm going to use the property that the integral of anything of that form is this. Yes, that's a very nice formula. So what I will do, I will use it and solve. After I will prove why, because some people will be confused. How come this is that? So let's solve. So from this, now see that integral of e raised to power 2x cos 7x dx is now, so our a is 2 and our b is 7. So I have e raised to power 2x 2 squared plus 7 squared of 2 cos 7x plus 7 sine 7x plus k. So that's it. So which is e raised to power 2x. 4 plus 49 is 53. 2 cos 7x plus 7 sine 7x plus k. So that's our answer. Verify within 1 minute. So let's now prove why that is equal to that. So as you can do, this product, so we use integration by parts. And we know that integration by parts is always of this form, that integral of u dv is uv minus integral of v du, where u depends on the value here, because the one you assign u has a lot to offer. Because if you assign any function u, you might keep on integrating this. So from experiments, they have noticed that the order lipte is the key. So you have to look out for L, meaning logarithm. If you don't see log function, you look out for inverse, trig. If you don't look out for, if you don't see, look out for polynomial. If you don't, look out for trigonometry. Remember, this is inverse trig. Y finally exponential function. So that's the order of u. So looking at this, our u is trig, because the trig comes before exponential. So we now have, so if you call u, the other one is now dv. So our dv here is e raised to power as dx. So I have, therefore we have integral of e as cos bx dx is now u. Our u is cos bx times v. V is now integral of e raised to power as, because dv is this, is e raised to power as dx. So integrating both sides, we have v. So integral of this is e raised to power ax over a minus integral of our v is e raised to power ax over a. Why our du? We differentiate cos bx is now minus b sine bx dx. So we'll continue. So I can write this is first eax over a cos bx minus, okay, we can factor minus times, so we have plus b over a of integral eax sine bx dx. So we need to do the integrations the second time, because we can still, but now our u is sine bx, while our dv is e raised to power as dx. So we have that, let's move this so that to contain, we have is equal to e raised to power ax over a cos bx plus b over a. So we now apply integration by parts here. We apply this again, so our u is that, so I have sine bx, and our v now, integral of this is e raised to power ax over a minus integral of v, which is e raised to power ax over a. If we now differentiate this, we have that is equal to b cos bx. If you differentiate this, that's what you have, dx. So we have that this is e raised to power ax over a cos bx. We open up, no, this is the bracket, this, so ba times this is b e ax sine bx over a squared. This times that is now minus b times b, that's minus b squared over a squared of integral. Do you get this times this now? Plus times minus is minus, b times b squared, a times a. So we're left with integral of e raised to power ax cos bx cos bs dx. So if you look at this, we are asked to integrate this, and if you look at this, that's what is here. So if you keep on integration, it won't end. So we now use our common sense as mathematician. We collect like terms. This and this is there, so we move this to the other side to be positive. So we have this, so we'll move this to the other side, which is now equal to, this goes to be positive. You have b squared over a squared integral of e raised to power as cos bx dx plus integral of this bx dx. So we have moved this to the other side, remaining only e raised to power ax over a cos bx plus b e raised to power ax sine bx over a squared. So what do? What is common here is this and this. I factor that. So if I factor that, I will be left with b squared over a squared plus 1 of integral of e raised to power ax cos bx dx. Do you get? I factored. If you multiply this times this, I have this times this, I have this back. So we're making the subject of formula y here. The LCM is a squared. A squared in a squared is a times that, so I have a e ax cos bx plus b e ax sine bx. So that's what we are left with. So but we can still write this, the LCM is a squared, so I have b squared plus a squared times integral of e raised to power ax cos bx dx is equal to this. So if you notice, what is common is a squared. So a squared, we are left with, we can write this as a squared plus b squared, which is the same as b squared plus a squared, integral of e raised to power ax cos bx dx is equal to a e raised to power ax cos bx plus b e raised to power ax sine bx. So finally we'll make this the subject of formula. That's what we are looking for. So we'll make this the subject of formula, which is now therefore the integral of e ax cos bx dx is 1 over a squared plus b squared. Do you get? Dividing both sides by that. So we are left with times a raised to power a times e raised to power ax cos bx plus b e raised to power ax sine bx. So we can still see that what is common in both is e raised to power ax over a square plus b square of a cos bx plus b sine bx. So that's the formula. Okay, maybe plus k plus the constant. So that's our formula. That's why we used that very fast. We are given that, we don't need to waste our time. So that's it, the same. So thank you.